Okay, computer hardware. They're the physical parts of any computer. So they're the things that you can physically see and touch, bits of electronics, things that you can see on a screen. Anything like that is known as computer hardware. So, what is a computer itself? So, a computer is any device, it's an electronic device that can process information. So, by process, it means it takes information in an input form, it manipulates it, and then it sends the information out. It does something with the information. So, it will give you an answer, a result of some kind. And the most basic one, if we just keep on referring to the most basic computer that you have in school at the moment, that would be a calculator. So you put numbers into the calculator. When you've pressed an equal sign, you're going to get your result, which is your output. And if it's plus, minus, divide, whatever, that's the processing instruction for how we're going to take the input and process the information, the input, to give an output. And that output will then appear somewhere on a screen for you so you can use. Okay. So first thing that I need you to do is in your copybooks, I want you to write down what are the computers that you use. Now make sure you've got an explanation of what a computer is. If you feel that you need to go back and rewind, no problem at any stage. You may need to do this because I'm expecting that as we go through this, you're taking notes on this because obviously these things are likely to appear in your test. So first exercise is I want you to list the computers that you use. Feel free at this stage to pause and think about all the different computers that you use, computing devices, processing devices that you use, both in school and maybe at home as well. Okay, I'm presuming at this stage now that you had paused and you've listed your computers, and now we move on. What do these things get used for? So beside each, in your list, so you got a list of names of different devices. I want you to write down on the right hand side, what are they used for? So if I just give you the really simple one, I'm presuming in your list, based on what I did at the very beginning when I talked about what a computer is, well, the most basic one you have is a calculator. So what do you use them for? Well, you use them for doing maths calculations, for doing sums, arithmetic, whatever, okay? So that's what I would use a calculator for. With your other devices, can you think about, well, what do you use those things for? Now, just so you know at this stage, that list that you should have at least 5 different devices. But probably if you think about it seriously, you could have 15 devices. So in each case, again, you'll be pressing pause after this. In each case, just think, what do you use them for? Okay, so this is where, for classwork, I would have expected that on your own, you've listed your computers and what you use them for. So maybe have a look at what some of your neighbors have done and think about 2 other devices that you have at home and 2 that you might see maybe on the street, somewhere outside of the home. And what are those devices used for? So again, name the 2 other devices you'd see in your home. So when you walk in the door of your house, what computing devices do you see there? And 2 of them that maybe are outside of home, and what are they used for? So again, this is classwork. And again, after that, I'd expect you to press pause. Okay, next one is we're going to look at input devices. And there'll be an assignment there at the bottom. I want you to add to what you've done so far. Remember, all of this work is going to have to be uploaded to OneNote as you do it. You can do it on stages or you can do it at the end. So the input devices that we have. So these are ways of sending data to a computer. So what is data? So data is any type of information on a computer. And the most basic form of data is called a byte, B-Y-T-E. So when we talk about things being gigabit or megabit or terabit, then it's millions or billions of bits of information. So a byte is a bit, okay? So that's the smallest size of piece of information for your computer. And if we have talk about lots of data, then we have lots of bytes being stored. Okay, so input is how do you put this information into a computer. So the normal way we would think about is a keyboard. So that's the most obvious way of me putting information into a computer. You also have things like a mouse. So a mouse gives instructions. You can move a mouse around the screen. You can click on it. So when you click, you're giving information to the computer so the computer understands better how to start processing the information. You can have cameras putting information in. So you could have, for example, you could have a system that records the movement of people or records people's faces. And we use that as a way of sending input to your computer, telling your computer how to operate. So should I allow this person in, yes or no, based on, let's say, a fingerprint that I've just done on, let's say, a phone security device. So you've got a joystick. So if you think of, one of the examples that you should have had of computers at home is more than likely a gaming machine. So a lot of people are interested in gaming now. So whatever joystick you have, but even if you could use joysticks for other things that are nothing to do with gaming. So if I want to move a complicated machine, I might have a joystick that will allow me to move that machine. That machine is still a computer, because it's moving lots of different parts as a result of the instructions that I send in. So the input that I give from my joystick. I could even record information. So spoken voice, that again might be something that is input. And again, think about the computing devices that you had from the previous exercises. Well, are there any of those that respond to input that is, let's say, from a microphone? Okay. Now, aside from these devices that we have here, again, I'll be pausing now in a second. Aside from these devices, can you think of any other ways that you could input data, or you could call it instructions, or you could call it information, but that you can input into a computer? Think of any other way. And again, you should be pressing pause here after this. So, output devices. So this is how does the information which has been processed, how does that get used? How is that sent from the processor? What do we do with the results of the processing of our input? Okay, so an obvious one is that it'll appear on a screen. So I might use the most basic output or input device, which is a keyboard, and I might type on the keyboard, and the screen, which is also known as a monitor or a visual display unit, a VDU. So you might display in your VDU the text that you're typing or your calculations, or maybe you're gaming and you're looking at a screen of some kind. It's still a monitor, it's still a VDU. You're still displaying information that is output. So when you move maybe a joystick or whatever, you might see on the screen the results of your movement. What does that do? So that's your simple output device. Speakers could be an output device. So when you're gaming or if you're listening to music, you've given instructions to the computer by clicking on a mouse. Maybe think about your phone as a simple computer. You've clicked on a certain button and you got audio starting to come out through the speakers. Okay, traffic lights, you mightn't think, but they're a computer. So if you think about it, you've got different lights coming on at different times, and there are sensors associated with traffic lights. Traffic lights don't just necessarily go red for 60 seconds and then go green for 120 seconds, whatever. It's not necessarily just a timer, but if it was, then the processor is processing a clock. So it's got a time element in its instructions of how to operate. And when somebody presses start, that means then start the traffic lights working, then the timer will just output different lights at different times based on the clock. But you could also have attached to the traffic lights, you could have sensors. So there might be some way of recording that there are cars waiting in a big queue. So we might need to send one set of traffic lights red so that we can start sending another set of traffic lights green. you might have a pedestrian crossing at a traffic lights. When somebody presses a button, that's a sensor that gives input information. So the button is an input device, and we might process it, and it might decide to keep all the lights red. Because if you think of traffic lights, you've got multiple lights all been controlled by one computer, and it'll keep all of those lights red and turn a different light, the pedestrian light, green. And that will do that for a period of time. But that's all of those instructions for the pedestrian light, that all came from you inputting a button in a sensor. So the output itself is the light, and part of the instructions that it gets, the input, could be a sensor of some kind. So a car engine has, nowadays, they're controlled by computers called an ECU, an electronic control unit. Some people might call it an electronic computer unit. So this is the brain of your car, and it's got loads of sensors, and it tells the engine of the car what the pistons are doing and what the spark plugs are doing, and it will pump fuel into the engine to make the engine work. And it does that. The computer controlling your engine, controlling your car, has sensors all over it. So it might spot, for example, your headlight bulb is gone, and it'll give you information on a little monitor on the dashboard. It might spot that maybe the oil level is in your engine is low, which would be bad for the engine, and it'll give you a light so that you know what to do about it. It also will control starting the engine and making sure that the engine is ready to start, and it might have certain processes it has to do. So the output that you get from your car engine, from all those sensors, the output is an engine that starts moving. So you might necessarily realize it, but when the car engine starts, that's an output. Okay, so all of the actions that are happening, that's output. Another one, if you think even more complicated than that, is a plane. So if a plane is landing, then there's a huge amount of things that have to be controlled. You might say, well, lowering the wheels might be straightforward enough, but there's loads of different motors that control all of those different wheels. And when those wheels are lowered and they're locked in position, there are sensors that will tell a computer that the wheels are now locked, so the pilot knows it's safe to try and think about landing the plane. And then on top of that, you've got computer controls that are controlling the movement of the wings and the angles of the flaps on the wings, even controlling the engine. So all of those are output devices. Now, can you think of any other output device? Again, we'll go to pause here now. Think of another output device from any computer system. Now, maybe think about the computer systems you had in earlier classwork. Can you think of any other output device from any of those? Again, we'll go pause now for a minute. Okay, so the CPU. So this is kind of vital, and you need to make sure that you take notes on this, because obviously this is the type of thing that's likely to come up in a test. But the CPU stands for Central Processing Unit. So this is the brain of a computer. So the brain has to process information. So if you think about the human brain for a second, so if I have input in my eyes, so my eyes are a type of input that are sending signals to my brain. So if my eyes recognize that there's a light that's red, then my brain will process that and say, well, red means stop. So if I'm in a car and I see red, then I should be stopping. So that means that the output for that is me. If I happen to be walking, the output is me stopping moving my legs. If I happen to be driving, the output is me pressing on certain buttons so that I'm actually doing something. So the input was the signal going into my brain. The brain processed it according to a program. Now, so the program I'm talking about is the activity I'm doing. So if my activity is driving and my input is red, then the output will be me pressing certain things with my feet and possibly my hands as well. If the activity I'm doing, the program that is running in my processor, in my brain, is walking, and I see red, well, that might mean that the output is me stopping moving my legs. Okay, so that's how the CPU operates by deciding how to process the input that it's getting, the data coming in, to then give it some kind of result. What is the output? What happens with that data? What instructions are being given? Now, to be able to do this, okay, we will have to have a series of instructions. We'll talk a little bit about that before. But what I want you to do is the first exercise here is, again, we'll pause after this. Just think of some data being processed in school. So what instructions, what input do we have in school? Make sure you think about what is the input and what is the output device associated with that data which is being processed. Again, can you record that on your copybook? And that will be getting uploaded to OneNote when we're finished. I'll just go pause here again. Okay, so computer memory. So we said before with the processing unit, it's processing information from the brain. Okay, so the brain has to decide, well, how do I process it? What are the programs? What are the series of instructions that I have to start operating on? No, those instructions are known as ROM, which is read-only memory. Read-only memory. So this is memory which is stored as a series of instructions which can be used or read from, but the computer or the person using the computer can't alter those instructions. Okay, now so the simple instructions might be, in my brain, when I've learned how to drive a car, I will have a series of instructions that I know that I will apply in car driving mode. So my arms are going to do certain things. My eyes as an input are going to notice things. And what do I do when I notice this? What do I do when I notice that? If I notice that lights are going amber, I'll start to slow down. That means pushing my feet. If I notice that there are cars ahead of me, I'll start to slow down. If I want to go left, I'll press indicators. All of those things that I've trained my brain to do, that's all in those instructions, which are never altered, are all stored in read-only memory. Now, the read-only memory, I'm using pictures here of a library. So when we talk about read-only memory and how big the memory is in your computer, you have apps or programs on a computer, which we'll talk about in future classes. But when we talk about the size of a computer's memory, we might talk about, think of it in terms of libraries, where you might have, in this case, on the left-hand side, I've got 3 shelves, or you've got a massive library with multiple shelving units. So that dictates the size. When you talk about a modern laptop, maybe it has 1 terabyte of memory. That's 1 billion bits. Remember, bytes, they're the most basic form of computer memory. We'll have 1 million bytes, million individual pieces of data, or even more, billions of it stored on our computer. So think of it in terms of a library. The more shelves in the library, the more instructions and information you can store in the library. Now, RAM is random access memory. Okay, so random access memory is any instructions or any data stored in a computer that I can manipulate, I can use. So I think of it in terms of, imagine that you've got a desk and you have 1 book open on it. That desk is so small, all you can do is open 1 book. As opposed to a much larger desk where you can have loads of books all open at the same time. That means you can have loads of pieces of information. Now, the memory itself is a file. So maybe I've used a computer program like Microsoft Word to write a letter to my auntie. Well, that's a file, and I'm manipulating that data. I'm manipulating that file. So I'm using a program which is ROM called Microsoft Word, and I'm using that program to create my own file, which is a letter to my auntie, and I'm typing text into that letter that I'm sending off to my auntie. So that's random access memory. It's memory that I can alter. I can change that letter. I can change that file. How I open that file, I used a program, and we'll talk a little bit more about files or applications and files later on, or programs. But those programs are stored in ROM. whereas RAM is all the information that I have to manipulate. So the memory of a computer is actually two different types of memory. So you've got read-only and random access memory. The bigger your computer, the more RAM you might have, more information you might be able to store. Now the thing about RAM is, the more RAM you have, and it's a specific type of memory, the more random access memory you have in your computer means the more tasks you can be doing at any one time, the more books you could have open. So to give you an example of how this might work, if you're sitting at home and you're watching, let's say, on your phone, or maybe you're watching on a laptop, let's say something on YouTube. While you're watching YouTube and hearing the output of the sounds that are on that video that you're watching, at the same time your computer could automatically be downloading emails for you, or it's got Teams open and you're getting Teams messages. Now, maybe nobody is sending you a message at that moment in time, but Teams constantly is checking, are there any notifications waiting for you, and it will go and get them. You're not even aware. It's doing this all the time. So you now have YouTube open, you've got Teams open, maybe you've got Snapchat open as well. You've got multiple apps open. Now, if you're watching your YouTube video and you start to notice that the thing pauses, or maybe the video starts to get poorer, the sound starts to deteriorate, what's actually happening is your device can't cope. It doesn't have enough RAM to cope with all of the tasks that you're using your device for at that one moment in time. So that's how you would know, like when you talk about, the size of RAM and why RAM is so important. The more RAM you have, the more tasks you can smoothly be managing at any one moment in time. And if you want to do something that involves lots of graphics, video being the most heavy, or gaming in nowadays, because gaming has such really high quality graphics, well then you need to make sure that you have more RAM. Okay, so just make sure now, just before we finish, you need to just take some notes on what is the difference between ROM and RAM. Maybe use the textbook to help you, or maybe just go back and re-listen to this video. We're going to pause then after that before I move on to the next slide. Okay, so this here is your first piece of homework. Okay, so this really should get done by the end of the week. So first thing I need is I want a diagram that shows how the CPU operates. Okay, so it should have arrows, it should have labeling different parts. Okay, if you're stuck, you can have a look in Google, but try and see if you can do it based on the information I've given you in earlier on when I talked about CPU. And make sure that I can see where is input, where is output, and where is memory. Okay, for any computing device. You don't think necessarily about one particular device, but think of any computing device. Okay, and remember the most basic computing device you have is your calculator. Second thing I need you to do is a one-sentence explanation for what all of those terms there mean. Okay, so again, go back, have a re-listen to the video if you need to, but can you make sure that you have a one-sentence explanation of all of these, upload it to OneNote. And remember, please, this is something that's going to feature in your summer exam. Okay, obviously I'm going to be marking as part of homework, and I'll send comments on to your teachers after, but it is part of your summer exam. Okay.